Section 5.5, quadratic equations. In this section, we're going to solve quadratic equations either by factoring or by finding their square roots. So to start solving by factoring, we need to know two things. The first thing we need to know is what the standard form of a quadratic equation looks like. In this form, we want to have our normal ax squared plus bx plus c, but you'll notice that it has to be equal to 0. We're going to use that in combination with the zero product property. And the zero product property simply states something that you're probably very familiar with. It just says that if I multiply two or more things together, then one of those items, one of those factors has to be a 0. Otherwise, I wouldn't get 0. So in the case of using that in a quadratic, two things I know. I can factor a quadratic function, or most of them, into two factors that are being multiplied together. So in my case, I would consider the first binomial factor to be like the a, and the second binomial factor to be like the b. And if I know that any product equal to 0 means that one of the two parts of the product has to be a 0. So what that tells me about this is that if the a part and the b part, the two things that I'm multiplying together, one of those would equal 0, then I would end up figuring out what the solutions to that could possibly be. Okay, so we're going to look at how that works with solving by factoring. Okay, so to do that, the first thing I'm going to do is make sure that my equation is in standard form. Okay, so if you look at my equation over here, it's not in standard form. I would need to move the 15 to make that happen, right? It's got to be equal to 0. Okay, well, no like terms, so this just comes out to be 2x squared minus 11x plus 15 equals 0. Okay, then I'm going to factor 2x squared minus 11x plus 15. And when I factor it, what that's going to do is it's going to give me two things in my product, two terms for my product, and then I will find out what those equal when they equal 0. Okay, so to factor this, you can factor it by whatever method you're comfortable with, whether that's guess and check or use, in this case, maybe the factoring by grouping. You can do either one of those things. Okay, so I'm going to factor mine like this. I know I have to have a minus and a minus. Trying to make negative 11 in the middle with a 15 at the end. So I think what I'm going to try here is 3 and 5. Okay, and if I check that, 2x times 3 is a negative 6x and a negative 5x, so I'll get a negative 11 in the middle. Okay, so those equal 0. Now, the next step is to use the zero product property. So what this tells me is if I have 2x minus 5 times x minus 3, then one of those two things has to be the part that's giving me the 0. So what I'll do is I'll just find out what that is. So I'm going to take 2x minus 5, going to find out what would make that 0. Then I'm going to take the x minus 3, which is my other factor, find out when that would be 0. And instead of getting one solution to the problem, I'll get two. And if you think about the way a quadratic function, when you graph it, right, it's a parabola where you have those corresponding points, so you're going to have two values that give you the same solution. So here's what I'll do. 2x minus 5, this is just a simple two-step equation. 2x equals 5, x equals 5 halves. Now, since that's a nice terminating decimal, I could go ahead and say that that's 2.5. Now for the other side, a one-step equation, I add 3, and I get x equals 3. So I actually have two solutions to this problem, x equals 3, or x could possibly be 5 halves, or 2.5. Okay, so the second way we can solve a problem, besides using factoring and the zero product property, is to use the square roots. Now this method only works if you do not have that bx term in the middle. You have to have only an x squared to be able to solve this by finding square roots. So you'll notice that none of my equations here have that bx term. One thing that I do differently with this one is that instead of having it equal to 0, I actually want everything away from my x squared and move to the other side of my equation. So like on my first example here, what I actually want to do, it's equal to 0, it's equal to 0 already. I want to actually make this to where x squared ends up all by itself. So to do that, I start by adding 180 to each side. And when I add 180 to each side, since that side is 0, I get 5x squared equals 180. My next step is to divide by 5. And I will get x squared equals 36. Now, we would be really tempted at this point to say, oh, okay, well, x equals 6. However, the problem with that is, and we've talked about this in previous sections, is that there's more than one way to make 36 when you square a number. You could make 36 by, when I square root each side, by using either a positive 6 or a negative 6. So a lot of times you'll see the answer written like this. What I would like for you to do, so that you don't forget that there's actually two solutions, is to tell me that the answers are both 6 and negative 6. I want you to write them out separately like this, okay? Because there are two solutions. Okay, let's try the one in the middle. This time I have 3x squared equals 24, so the 24 is already over there. I want to leave it where it is. I just need to move my 3 by dividing both sides by 3. 24 divided by 3 is going to give me 8. To figure out what x is, I'll just square root both sides. And I get x equals plus or minus the square root of 8. Now for some of you, if you remember from geometry, you would simplify this radical a little bit. This would simplify to 2 square root 2, which would also mean I have negative 2 square root 2. For those of you that aren't so familiar, for right now, if you want to go ahead and tell me it's the square root of 8 and negative square root of 8, I will be okay with that for the time being. We will eventually do a little more with simplifying radicals, but for right now, that's not really the focus. Okay, now the last one over here, 4x squared minus 20 equals 5. Same process. Start by moving everything away from the x squared. So I get 4x squared equals 25. Then I divide both sides by 4. Now one little trick I'm going to give you here. 25 and 4 doesn't go that nicely into 25, and I also am thinking about the fact that I'm working with square roots here, and 25 and 4 are both perfect squares. So unlike what I would normally do, which is either go ahead and divide this or try to reduce it, I'm going to leave it because since I know that I'll be square rooting both sides, it's much easier for me to square root a 25 and get 5 and a 4 and get 2 and get 5 halves than it is to try to reduce that fraction and then, or make it a decimal and then try to square root it. Okay, so what I really end up with is positive 5 halves and negative 5 halves, which is positive 2.5 and negative 2.5. Okay, or you're more than welcome to leave it as positive or positive 5 halves and negative 5 halves would be acceptable as well.